So, I'm Deniss Ločmelis, Technical Director at Tesla Lab. I'm leading R&D initiatives in audio and video testing. And I'm here today to tell you a little bit about audio and video testing. With me here today should be Adrians, but he's late. And we're gonna use Google Meet to call him in. So let's do that now. Hey, Adrians, can you hear us?
Yeah, I hear you good, mate.
Oh, we can hear you as well. Cool. Really good to see you. So I think an introduction is due. Whenever you're ready, go ahead.
Yeah, I can do that. Yeah, sure. So, hey everyone. Good to see all of you. I'm one of the audio and video testing engineers, currently managing one of the video conference tool benchmarking projects. We are comparing various audio and video quality.
Adrian, I don't know if you can still hear us, but you're really lagging.
As Google Meet, as Zoom, WebEx, and so on. I'm really excited to be here and share audio and video testing experience.
So apparently network is not as great as it's supposed to be. So Adrian, if you can hear us, please come here to the stage because we cannot really hear you. It's awful. All right, man.
I'll be there in a second.
We're waiting for you here. All right. See ya. I don't know how many of you experienced this, like events like these, but there are certainly a lot of networks out there which video conferencing tool developers are aware of, and this is why they're really interested in actually doing real testing on video and audio quality, and this is what we're gonna do today. So probably many of you already understood that this was a setup. So Adrians is actually backstage. He'll be coming right up on the stage at the very moment soon. And what had happened, we did the recording. I did the recording on my end. And Adrians did the recording on his end. So there's an actual recording of our version of the degraded video right here. We can see it's choppy and everything that we witnessed. And Adrians has already sent us his version, which is the non-degraded one. So this is the reference video. And this is the network capture. So we'll also analyze network to see what happened on the line. We're going to quickly go through the analysis process of video, audio, and network. So let's start with video. There are specific metrics that we can analyze video quality with. One of the most popular ones is VMAF. This is full reference video quality algorithm developed by Netflix. For it to work, we need the original video, which is non-degraded, and we need the degraded one, which went through the line and actually experienced problems. We also have such a metric that which is called VQTDL. This is in-house developed algorithm. For it to work, it doesn't need the reference. So it just needs the degraded one. It's a machine learning algorithm. It will try to predict the MOS score, mean opinion score from 1 to 5, and tell you what a human would rate the video quality at. For the last metric, we will look at frames per second, which is there to determine video fluidity. It's basically how many frames displayed per second will be viewed. Then we have the audio. So for audio analysis, we can use, again, different mass prediction algorithms. One of the best we found in our practice is Polka. There's also Viscal, developed by Google, that's still in development and still can do better. Usually also audio delay is measured, so we know how much of the voice delay is happening through the wire. And last is network analysis. So to understand when the video conferencing app is behaving badly and why it is so, we look at the network traces. How to understand this is if we're having like two participants in call, like here on the screen, two laptops. Between them, there's a connection. So it's like a pipeline, and what we measure is the width of the pipeline. It means how much data is actually able to come through. So if the network, so it depends on the network quality, network infrastructure. So that will give you this width of the pipeline. The smaller the width, the less the network will flow through. So the width is called bandwidth. In bits per second it's measured. If the network infrastructure is not as good as we'd imagined, there will be some packets that will fall through, and that's called packet loss. It's measured in percentages. Okay, so this is for the process, and yeah, we can start by actually doing the analysis. So for video analysis, we have a script. Adrians, hey. Finally, man.
Feeling good? Woo! Nice to see you.
Yeah, nice to see you, man.
Yeah, so...
Okay, yeah. So Adrians is back, and we can start launching the script. So first of the script we'll launch for full reference analysis. We do have the degraded and reference videos. Let's just check them out once again. Okay, so one, I think, is in downloads. Yeah, here it is. Let's move it to the testing directory. And we need to move the degraded one as well. So this is live testing, guys. Everything can go wrong. Yeah, degraded we'll also put here. Yeah, so now we have degraded and reference. Let's launch our script. So we don't have to look at, lines of execution in the terminal. I prepared a quick kind of walkthrough of kind of what this script is doing. So first thing, what it will do is determine how many frames there are in the video. So the video is animation of still images, right? So the script will look at all the frames in the video. It will determine how many frames there are. And there's this FFprobe tool, which is part of FFmpeg tool. I'll leave links and descriptions in the very last slide, so you also have this information. After that, script will determine the frame rate as well. So it's average frame rate, and we will need this for later analysis. I see that GIFs are not loaded, but yeah, we can continue. Frames, count of frames, frames per second, then it will try and find the start time of the video, because we don't need the whole video. If you noticed, Adrians applied something called markers on top of his webcam view. These are those kind of QR-looking markers, and those are needed to determine different things. Frames per second as well, if we want to see a specific frames per second measurement on the time scale. So what will script do is go through all the frames, and the first it can read the marker. It will identify the frame ID divided by FPS. That's why we needed the average FPS. And it will find in milliseconds the right starting time when the marker frame is actually captured. Later on, it will find the last marker frame. So it will go from the end of the video. So again, going in loop through all of the frames, still images, and find the first marker. Again, capture the end time in milliseconds. And then it will make the final cut. Yeah, unfortunately, there's something wrong with GIFs here. Yeah, okay. Just needed some reloading.
Yep, it works.
Yeah,
right.
Yeah. So for both reference and degraded videos, we'll have the whole length only with those markers. So you can see those markers moving. It's because each frame is actually identified by those markers. So after cutting, we'll have a desynchronization problem. So what it means is that on our degraded video, it will start with markers, but not necessarily with the same markers that Adrians had. Because he did the recording on his end, we didn't talk on the phone, kind of sync it up. So that will be our problem that we will need to solve. How to solve this problem? So the script will first identify all of the frames based on the markers. We have kind of 4 positions for the markers. 2 will be blank always, and 2 will be filled with those markers. So marker is representing 4 by 4 bit information, so 16-bit information. If we translate that to decimal, that's 65,563 at max. And in each frame, we have the previous frame ID and the current frame ID. As you can see, like 2391 is the previous, 7890 is the current. And on the next frame, we'll have that previous frame ID, marker ID, and the current marker ID. So this will actually allow the script to build the sequence and understand what is the right order. After the identification process, we need to solve this desync problem, right? So when we have those markers ID'd, we can now say, okay, let's find in the degraded video the first frame and the last frame marker IDs for the degraded video. So for the video that we saw everyone here, then the script will go to the reference video and try to match the same first frame and the last frame. So it will go through the frames again from the start, from the end, and match the same frame ID, as you can see here on this example. So it will do the same for the start, for the end, and find frame IDs. So in this example, it's 121 for the start, 2091 for the end. And eventually, again, calculate the time and cut it from the beginning to the end so it exactly matches the degraded. So now the synchronization problem is solved. We go and filter out the duplicates, erroneous marker frames, anything that stands out and it's not kind of properly used for evaluation. Here on this example, you can see that this, different frames, frame 121 and frame 122, is actually the same marker ID. We don't want that. We delete the second one that is considered duplicate. We go ahead and encode the new video using the unique image stills, and it becomes our new reference, clean reference video that we can compare to the degraded and provide to VMAF script, and it will be very happy that we did the filtering for it. And yeah, lastly, like I said, we provide this information to VMAF, and there's these additional metrics which help VMAF to perform as it performs. While I was discussing the process of the script, what happened is we got the configuration screen for full reference. We'll fill it out in a second. What we need to do is run an FPS script and the VQTDL script, which will predict the MOS score from 1 to 5. So we will run it now. It's running. And let's go to the configuration screen for the reference video. Here we have the cleaned up reference. This is how it looks. The video quality looks good. We will need to, for the script to see the markers, again, we check if it can find it. Yeah, I don't know if you can see properly, but it goes ahead and borderlines in red the markers. We need to change the marker range to 9,000, and for the evaluation script to work properly, we need to define the area of evaluation. So we'll take almost all of the Adrian's head here and a little bit of shoulders, and that will be the evaluation area. Now we will save the configuration file and close this window. So if we come back to the terminal, it asks, have you done with configuration? We're done with configuration. Hit yes, and now it will go through the process of evaluation. So Adrians, I know you captured network, right?
That's correct, yeah, I did. You want me to go through it?
Yeah, I think so.
Okay. Can you open it up for me?
Yeah, for sure.
Perfect,
this is it.
Perfect. So what we're going to do right now is analyze the network trace that I captured when we were in a call with all of you today. Right now at your screen you can see a network trace with the UDP protocol. First what we need to do is to decode it as RTP. We need to decode it as RTP because we want to see video streams and audio streams separately. Next thing what we will do, we will select our IP address where we send the data from. In this case it's 172 starts from. Then I'll show you the IO graph, which is the graph where we will see all the network data. Yeah, so give me a second.
So Adrians, is it true that we will be able to see exactly where the bad network limitation happened?
Yes, just give me a second.
Okay, what are you doing right now?
I'm right now putting in the RTP SSC for the video stream. Right now you'll be able to see the network usage just for the video. And in a second I'll show just for the audio.
So you're saying the streams are identified?
Yes.
Okay.
So as you can see, when we were in the call, you saw a great quality and very probably good audio quality as well. And when we were in the call at around 16 of a second, I applied a limitation around 300 kbps and 10% packet loss. What happened is that network drastically dropped towards 300 mark.
I'll stop you right there,
yeah.
Just to remind everyone here what you're talking about. So when Adrian says 300 kbps, it means that the bandwidth, the pipeline width that we talked about before, was limited. So usually what we receive like between two participants is 1.5 Mbps. That's
yes, around if two users connect to the call, we usually see 1.5 Mbps usage.
So yeah, if you're in a network infrastructure where you have at least, say, 2 Mbps network speed, down and up, right? Download and upload speed.
Yes.
So this is enough to have a two-person communication without issues, at least on the bandwidth side, right? Yeah. So you did the limitation on 300 kbps, and you ruined our experience.
Yeah. So the video script ended. Do you want to continue with it?
Yeah, but on the network part, I just wanted to say that packet loss, you applied packet loss as well.
Yes.
So 10% packet loss actually meant that 10% of all the packets, all the information that flows through the pipeline were actually dropped. So they disappeared. And that also degraded our experience.
Right now on the screen you can see that I actually lost the packets that Deniss sent to me, but we can't see the lost packets on the sending side. That's because we used in setup a different router where the limitation is applied after the data is sent. So we won't be able to capture the packet loss on this device.
Can you bring up the graph once again to see
Yep.
where the limitation happened?
Here you go.
So we can see like nearly on, like just before the 20th second, let's say it's like 18th of second, like 17th maybe, right?
Yeah,
16th.
it's around 16.
You applied the limitation, the network dropped. So actually now that when we analyze video results, we should see the same.
That's correct.
Mostly on video fluidity, I saw a lot of choppiness in the video and freezes. And also, at some point in time, the video quality should also degrade quite heavily.
So let's continue with the video results.
Yeah, so we have the results. We have a dude report prepped. And let's import the results. We'll start with VMAF, the Netflix developed algorithm scores. Let me bring up. Yeah, this is it.
Hopefully everything's going to be all right, yeah. Remember, it's a live testing.
Well, yeah, let's hope so. And importing the data now. So this is the graph. Wow, it seems to be working. Yep. Okay, guys, so here you witness the same, almost the same what we saw on the network graphs, right? We have this good quality at the very beginning. A bit of kind of VMAF is trying to find the right scoring to do because Adrians is moving. You know, there's different light conditions, and then when he applies the limitation on this like 18th second, it drastically drops. So there's this rapid drop, and then it goes down and tries to kind of maintain quality, but obviously it cannot. We also have the results for frames per second, and we also have the results for VQDDL, and actually we have results for freezes. For audio, we will not do the analysis today because, first of all, when applying this kind of limitation, the audio quality, so Google Meet is really good with maintaining audio quality when the network goes really down and degrades, right? So it kind of, how to say, prioritizes audio over video. So we're really interested in the video analysis right here. Let's import the frames per second.
Yep, let's do it.
Should be right here. This one.
We should see the frame rate drop as well when we apply the limitation. And
yeah, we need to
add VQTDL as well.
VQTDL.
So the graph is in correct form.
All right, here we go. Fingers crossed. All right, cool. Actually,
looks pretty good. It
has
really a bit of offset, but
it's really good. We see the correlation, the trend is there. The red line is the frame, are the frames per second. So as you can see, the very first like 10 seconds of experience is really good. Then the frame rate drops. We can see the quality being maintained, right? So if we look at the both video playback side by side, we should see very similar things, right, Adrians?
Yes, that's correct. We should see a low frame rate and a bad quality.
Yeah, let me bring it up.
And here's the newly made video.
Yeah, 36 seconds. Oh, okay. This is already kind of chopped frame by frame, right?
This is chopped version, yes.
Yeah. But let's look at where the quality drops. So we can see frame drop, obviously. We should see the quality drop right around 20 seconds. Yeah. So on the degraded video part, you can see blockiness, like this blurry picture, and the same we saw here as well. So both VQTDL and both VMAF shows us rapid drop, and this is our kind of objective way of measuring the quality. So we can get these scripts into any CI pipeline for video conferencing tool or even video on demand developers, and we can compare between different applications, so we can have benchmarking tests running for their competitors, or having all different kinds of evaluations for video. And I think this is everything we wanted to show. And I'm really glad that our live testing actually turned out to be well. And before we end, guys, if you have this question like, what do I do with this information? Where do I start? So check out, if you won't like to just look at different algorithms, maybe play with the code. So there's actual VMAF, and for VMAF, it's an open source project. You can go ahead and into GitHub on Netflix/VMAF, get all the code, go through the README, and get on with it. For Polka, unfortunately, it's a paid license. So for you to just check out audio quality evaluation, you can go to Viscal, which is Google-developed algorithm, so you can play around with that. Also, as an alternative to VQTDL, because VQTDL is still like an in-house thing that we're still developing. It's not open to public yet. But as an alternative, there's Brisk. It's also no reference algorithm that you can use and check out. As for tools, FFmpeg, FFprobe is used to cut the videos, work with decoding and coding the videos, getting the frames out. Audacity is used for audio editing, so you can use that to check out audio things. And Wireshark was used to record and analyze network data.
Yes.
All right, man. Thank you.
Okay, thank you.
And thank you all.
Thank you. And can I hear you? Do you hear me? Good. We have time for exactly one question. Who is the first one? And the only one? No one wants to ask questions. Then I have my question. I have had meetings over the ocean with people in the Boston, and I had this video conference from my car. So in case, let's say, I don't hear another participants, what is the first thing to do? What do you suggest to get the voice back?
Yeah, it's a really good question. Actually, if you experience any network degradation problems and the app is not behaving in the way that it should, reconnect. Because every video conferencing app actually has this bandwidth estimator, and if the network starts changing, it tries to catch up. Obviously, it will take time. So the best thing to do is just restart the damn thing.
Thank you.
The old restart always works. Yes, no reset.
That's the best way to do it.
Yeah, thanks.
Thank you.
Thank you.
Thank you.